All right, here's the video on area of regular polygons. One of the things that I always say when I teach geometry is that area of a regular polygon is probably the most difficult topic in your typical high school geometry course area and perimeter chapter. Why is that? The first thing that I usually say is it's brand new. No one has seen this before. Many of you have probably seen area of a triangle, area of a parallelogram. Some of you may have already seen area of a trapezoid, area of a circle in grade school. Nobody's seen area of a regular polygon. The other thing is there are quite a significant number of steps to your usual problem to find the area of a regular polygon. We should remember first that regular polygons are shapes that have two essential qualities that go together. The first is that all of the sides are equal, and the second that all of the angles are equal. When we have a regular polygon, this is actually from the textbook I normally use because I like it that much. We have a couple different things, qualities, parts that we will need. The first thing I want you to notice is this idea of inscribed. We've talked about this before. If you have a figure and you draw a circle around it in such a way that each of the vertices of the figure, each of the corners, sit on the circle, then you have inscribed the figure in the circle. You will notice that each of those vertices form an inscribed angle of PQRST. When we do that, we have a couple things. So the first thing is the center of the circle is the center of the polygon. So in this example, our center would be at point X. We have a radius. The radius is still the distance from the center to the outside of the circle. In this example, XQ or XR. Certainly you could draw a radius from X to some random unnamed point on the circle. Certainly you could do that with any of the other vertices, but those are the two that we see in this picture. Notice that XN is not a radius because it doesn't go all the way to the outside of the circle. Okay. Central angle is the same as what we've seen before, so we would say that RXQ is the central angle here. Again, if you draw radii to other points, you would have other central angles. The last thing that I sort of skipped over is this idea of apothem, apothem, you will sometimes hear people say. An apothem is basically the height of a regular polygon. That's how we're going to use it in our formulas. The apothem is segment XN. It's a segment that goes from the center of the circle, the center of the polygon, to one of the sides. And it is specifically the perpendicular bisector of the side. We see that it is perpendicular to side RQ, and I'm telling you that it is a bisector there. Okay, certainly we could write a proof for that, but we're not going to do that right now. All right, so for this video, I'm just going to jump straight to the formula. We're not going to derive it. The formula for area of a regular polygon is very much like the area of a triangle formula. 1/2 apothem times n, which is the number of sides, and times s, which is the length of one side. I usually use that one. But there is the other one there. If you know the perimeter of a figure, then you can use 1/2 times the apothem times the perimeter, recognizing that the number of sides times the length of the side is the perimeter. And again, that's because in a regular polygon, all sides are equal. All right, so we're going to talk about how to use this formula to find the area of a regular polygon. So if you have something like this, my usual tips for formulas always apply. Take the formula, 1/2 times apothem times side length times number of sides, and I'm going to explain why I switched those two variables when we get to it. So I write that down, and then I list all of my variables and what I know and what I might need to find out. The area, obviously, is what I'm being asked to find in this question. The apothem, see, we have the center. We can assume that is the center. And then we have the 9. We know that that's a perpendicular segment to the middle of the side. Our apothem is 9. We know that the side length is 8.7. And we can just count the sides. 1, 2, 3, 4, 5, 6, 7. So we have a 7-sided figure. We have an apothem of length 9, a side of 8.7. So now we'll use the formula. Area equals 1/2. And again, those things never change. And then we plug in our values. Now, here's why I use A times S times N. If you look at the figure, the apothem, I'm going to draw in the radii here. I know that I'm going through the 9, but I kind of don't have any other choice. We can see that that forms a triangle. In fact, an isosceles triangle, because we know that all radii are equal. And what happens here is if I create all of the possible radii going to the different vertices, I will create a certain number of congruent isosceles triangles. Those are all congruent through side, side, side. With that, I know that if I take the area of one triangle, it is the base times the height divided by 2. So we have 1/2 times base of 8.7 times height of 9. And what's more, if I take that and multiply it by the number of triangles, 2, 3, 4, 5, 6, and 7, I will have the area of that whole shape. Okay? As far as doing this, many times you will want to do that on your calculator. So 1/2 times 9 times 8.7 times 7. And I would get, for the area here, 274.05. And again, if they had told us inches, yards, miles, feet, we would have that squared. Right? I'm going to go through a couple more examples of different things you might see with area of a regular polygon. So in the next one, what happens if I only give you apothem? So the apothem here is 7√3/3. And don't worry, we'll make that into a decimal when we get to it. For this one, you have, and you know the number of sides is a triangle, you know the number of sides is 3. For this one, though, you need to know the side length. Now, there's a couple different things you could do. I'm going to show you what I think is the most reliable way to do this. Is it always the fastest way? No, you are going to have to use trig here. So, what I would suggest doing, you have the apothem. Take your apothem and part of the base here, and we're going to make a triangle. So you're going to need a radius. Okay? With this, I would suggest always doing it where the number they give you is on the outside of the triangle, just to keep it neat, because you're going to have to do some things inside. Okay, so the first thing you need is a variable. And I always use, because we said the apothem is the perpendicular bisector of the side, I always say that this is S/2. Why do I say that? Because that way, when I go ahead and find the variable s, I will actually find the whole side. You could certainly find whatever variable you want to call that and then multiply it by 2. I've just found in the past that a lot of students will forget to go and do that multiplication. The other thing, well, I don't know what the radius is. I only know one side of this right triangle, which means I have to use trigonometry. We know that in this, if I was to take, and I'm not going to try to draw it right now, the circle that is going to go around this triangle, I know that that circle has 360 degrees. And I know that the 3 central angles that I can form with this shape would divide up that 360. So I know each of those central angles is 120. Now I only have a certain part of it here in my right triangle. To be exact, I have half. So if you need to do this, if you need to get an angle to do trig, you're going to find one of these central angles, divide 360 by n. You'll get a number, take that number, divide it by 2 to get your angle at the top of that right triangle. And then from there, we can do trigonometry. So we would say that let's see, I would like the opposite of the angle, and I have the adjacent. I would say that the tangent of 60 equals opposite s over 2 over adjacent. And at this point, I'm going to go to the calculator to figure out what that is. 7 root 3 over 3 is 4.04. Okay, multiply by 4.04 on each side. And then I have s over 2 equals, and then 4.04 times the tangent of 60 is 7. Multiply by 2 on each side, and s equals 14. Now I know enough to find the area of the shape. Area equals 1/2 apothem times side length times number of sides. The apothem in its decimal form is 4.04. The side length is 14. And the number of sides is 3. So 1/2 times 4.04 times 14 times 3 is about 84.84 for our area. All right? Don't be afraid to use trig. Don't forget that you know trig at this point. That's something a lot of students will do. They'll forget the fact that they know trig, and then they'll get kind of stuck. All right, for this one, you know absolutely nothing you need other than the fact there are 4 sides. That is a radius, 13 root 2. You can't use the radius. You need the apothem, and you need the side length. That means using trig twice. I'm going to draw this apothem in so it's out of the way of 13 root 2. I'm going to show you another way to figure this out. We know that we have 360 over n, which is 4. That equals 90. So, and then we have to divide by 2. So each of these has 45 degrees. This is a 45, 45, 90. We know that in a 45, 45, 90, the hypotenuse is L root 2, which would make L 13. That would be your apothem. And then this is S over 2. So if S over 2 equals 13, then S equals 26. And then you would go through and find your area. Area equals 1/2 times 13 times 26 times 4, which is 676. All right, so those are just a few of the combinations. There are others. Thanks for watching.